Hello and welcome, Alex here. In this video, we will test ChatGPT and how it will generate code. My approach to testing LLMs for code writing tasks is try to write algorithm which doesn't exist in training data. And for this, I use algorithm to Demosaic raw image from Fujifilm X-Trans sensor. Basically, what is the goal of this task? Image sensors in digital cameras can sense color. To mitigate this problem, we put color filters before this sensor. So these color filters will pass only a specific color, and this means that this individual pixel can sense only one color, or like shades of green, shades of blue, and shades of red. But this means that for every pixel, we are missing two sorts of information. Basically, for green pixel, we don't know what is blue color and what is red. And to reconstruct this image, we need to do something which is called demosaic. And basically, we are using information from nearby pixels to estimate or interpolate, extrapolate, basically to guess, to reconstruct color values for other channels which are not in this sensor. Fujifilm X-Trans sensor has very specific pattern. It repeats by chunks 6 by 6 pixels, and it includes large regions 2 by 2 pixels of green color. And this pattern is, let's say, irregular, and it's less regular than standard Bayer filter. And this makes interpolation or demosaicing of this pattern is extremely, it's very hard task. There are no good and super fast and efficient open source algorithms available. And this makes task to write such a code is very challenging for LLMs, and this is why I use this task to test. I want to see if LLM is capable to come up with novel ideas, with novel approaches, and actually write code to solve some real-world problems if it doesn't have this data in its dataset. So I'm testing reasoning, but not knowledge fetching. Okay, let's return to ChatGPT. So latest release of ChatGPT 4.0, it's like latest and greatest, and we will test it right here, right now. I prepared a few prompts, and let's give it a try. So in this case, I write the best possible JavaScript code to the mosaic raw image from Fujifilm X-Trans sensor. Make sure to handle all possible corner cases and the mosaic artifacts. Provide final ready-to-use algorithm. So here I specifically ask to write code in JavaScript, because otherwise it will default to Python. And in Python, it tends to use third-party libraries like CV, etc. And it will offset this demosaicing to third-party libraries and basically provide me not algorithm to solve my problem, but some wrapper to call these third-party libraries. And it's not what I'm looking for. I'm looking to see how it will solve my problem, how it will write novel algorithm. So it's not novel, but it's not commonly available. Here I suggest that I want like pattern from Fujifilm Trans sensor. I expect that it knows its pattern out of the box because it scraped all internet and this information is available there. So I would expect that it will identify this pattern. And here I give it some hint. Please make sure to handle all possible corner cases and the mosaic artifacts. So I suggest, hey, I'm looking for handling these corner cases. So I'm like a little bit cheating and provided a little bit more information. It's not like specific details, but I want to make it curious and think about this. Okay, and provide final ready-to-use algorithm. Let's see what it will do for us. Okay, so it says like providing the mosaic in Fujifilm is complex task, blah, blah, blah. Unlike the traditional Bayer pattern, X-Trans layout uses 6 by 6 grid, which reduces more pattern and false color without the need for optical low-pass filter. Yeah, low-pass filter is basically camera manufacturers put small, let's say blur filter upfront the image sensor to actually like to make sure that every like ray or photon, not photon, like every ray of light actually hit not only single pixel, but to some degree hits nearby pixels as well. It makes image a little bit more softer, but this will reduce more is artifacts which happens on some repetitive patterns of very small fine details. So this low pass filter eliminates them, but at the cost of blurrish images. Okay, implemented in the Demosaic algorithm for this pattern requires careful handling of the CFA's unique structure. Right, correct. Okay, here's implementation. This code is designed to handle the intricacies of X-trans pattern and mitigate common artifacts such as false color and more patterns. Okay, sounds promising. Okay, get pixel, interpolate green. Okay, so ChatGPT knows that it needs to interpolate green at first. Oh, not at first, I will check this later, but we need to interpolate it differently from red and blue pixels. Why this is the case? If we'll take a look on green channel in this pattern, we can see that we have like a lot of green pixels. And this is as a benefit of X-trans sensor. So we need to basically reconstruct only a small portion of image. And we have a lot of information around each pixel. So for example, if we want to reconstruct this pixel, we can use information from this pixel, this. So a lot of information available for us. And usually, yeah, it's a great idea to construct green channel at first and reuse this information later. And if we'll take a look, for example, on red channel, for red channel, it's much more complicated because we have much smaller numbers of red pixels available. And for example, if you want to reconstruct, I don't know, this pixel, you have like 3 pixels nearby, it's not that bad. But if you have, let's say, some features, some horizontal lines, and for example, these pixels all black, but these pixels are fully red, like 255 or like 100% red, most likely you want to interpolate in this direction, not use like black pixels from here. So you need to do edge detection, feature detection, etc., and interpolate a little bit more clever. And yeah, it depends basically on the direction in which you want to do this. Okay, so let's return to the code. For green channel, it just use bilinear interpolation. It gets pixels on the left and on the right, and just averaging them. Do the same for oh my gosh, do vertical, the same story, and just averaging. But how it will handle, for example, case, let's take a look. So it's, for example, we want to demosaic this pixel, right? It will use this value, this, and this, so 4 pixels, and average them. But since here we don't have any value, any color information, does this mean that it will use 0 and this will skew the interpolation? It's a very strange approach. So this code won't work properly, unfortunately. So nice idea to interpolate green at first or separately, but very bad implementation. I'm not happy about this. Let's move on. Red blue. For red blue, it does slightly different. It, for some reason, it uses diagonals. Basically, it interpolates in diagonals. It gets 4 pixels, and let's take a look how it will work. So here is our, let's imagine that we want to interpolate this one. So it will use this pixel, this pixel, this pixel, and this pixel, and average them, right? -1, -1, +1, +1, +1, -1. Yeah, so basically all combinations. Yeah, so it completely ignores this pixel, completely ignores this pixel, and so it's a very strange approach. Again, it will work terrible. and I don't know why it's called bilinear at first place. Okay, let's take a look on actual Demosaic. So it will iterate through all image. So this most likely, so it's typical way to understand the color of the pixel. Basically, it uses information from CFA array. Basically, it enumerates all these pixels to the array. And for example, first row or fourth row and first pixel is, so basically CFA pattern is encoded in this condition. I won't test it because like I'm a little bit lazy to do this right now. I just assume that it's correct. If not, it's relatively easy to fix. So it gets pixel, interpolate green at first, and then interpolate red, blue, and just interpolate blue. Okay, so for red pixels, interpolate green and interpolate blue. For blue pixels, interpolate everything. Okay, so this is very simple, very straightforward approach, and unfortunately, it won't generate any like precise or high quality results. It will just do something, probably not super bad, but it won't generate any meaningful or, again, accurate image, unfortunately, just because approach is very simple. Okay, everything else is just placeholders. Okay, let's try and let's double check. So this was 4.0. So this is GPT 4.0. As we can see right out of the box, it can't actually write proper code. So it's not even close to AGI. Used approaches are very simple and primitive, I would say. So this is something that some code then like software engineer can write, let's say using whiteboard out of the head. And it's not great, not better than like normal software engineer, so anything great at all. Let's give it another chance. I have another prompt here, and I will try it. So my second prompt is much bigger. I provide much more details here in this prompt, much more instructions, some ideas like chain of thought, concept, etc., to give it more chance to success. So again, I request to provide JavaScript code. I suggest that it's a complex task, but I want to see like all optimizations and refinement for production use. I provide additional information on requirements themselves, like consider interpolate green channel at first. Basically, why do we want to interpolate a green channel at first? Let me illustrate this idea here. So if we'll have all information for all pixels, like for green channel, we can use this information to guide interpolation for red and blue. This is done usually, like the idea is following, basically in any region, like small region, like 3 by 3 or 5 by 5 pixels or 6 by 6, most likely relation between green, red and blue pixels most likely is the same, because like on small area, most likely we will see the same piece of image and color most likely the same. This means the delta between red and green in one area is similar like in another. And this means that we can, for example, when we'll reconstruct red pixel here, not here, like we will reconstruct red pixel here. We can calculate, and if we have green information for green pixel here, we can get delta between red and green in other areas, on average them, and then apply the same delta here, because we know like green information in green channel, we can subtract this delta from it or add it and get and calculate the red pixel using this information. So this is like typical approach, and I suggested use red-blue channels to assist in green channel interpolation. This is like another approach, reverse. Like, yeah, if we have red information nearby available, again, we can somehow reuse that information to guide green channel interpolation. But usually it's not the case. Okay, select proper size of interpolation window to include enough red-blue pixels. Why this is important? Because, for example, for green channel, or for red channel, right? If you want to interpolate, for example, or on Demosaic this pixel, and if you have horizontal edges, lines, or features, most likely you will want to interpolate between these two pixels using some kind of gradient. You won't include like this and this, but you need to have pretty large window to get pixels from. And this requirement suggests LLM to pay extra attention to these details. Okay, use the already interpolated green channel to guide red-blue interpolation. Okay, we already spoken about this. Feature-aware interpolation. Utilize the features data from the image to select most accurate interpolation method for each pixel. So basically, I want to see content-aware interpolation here. Okay, distance-based weighting. Closer pixel have more influence on the final value. Again, this could be visible here. If you interpolate this pixel based on these two, most likely this red pixel will impact on color for this pixel much more than this. So we need to do some gradient here. Implement edge detection and preservation. So I want algorithm to be content aware, and if we have edge, interpolate in proper direction. Implement false color suppression. False colors is a problem when I will illustrate it using like this line. So if we have like some diagonal, for example, line, white line, one pixel width in width, it will hit random pixels on our pattern. Let's imagine that it will hit mode multiply. So currently, it hits all green pixels. It's okay, but if this pattern will like hit these pixels, it just will happen on another area of sensor. We'll get random pixels, random colors. Maybe not random, I don't know. But well, if you will try just to mosaic them using some averages, etc., you will get all random colors here. Like between green and red, you will have some orange. Between red and green, you will have magenta, etc., etc. So you will see not white line. You will see some color noise. Especially not on these pixels, but on nearby pixels, there will be color halo here. And usually this is not a good idea, and you want to suppress this. This is called false color suppression. I want to see LLM to come up with this implementation. Implement noise handling. It's just nice to have from my perspective, but again, if LLM is truly AGI, it should be able to implement this, right? Implement more reduction, use adaptive interpolation based on local image content, implement iterative refinement, etc., etc. So I have a few more requests or requirements. I provide, just in case, a correct pattern for external sensor. Basically, it's position of these filters in array. And also suggest LLM, hey, before providing the answer, reflect on the task, build a plan how you would achieve it, consider what color, what could be improved, and only after that provide the final answer. So I give it some suggestions, use like chain of thoughts. It's not recursive, etc., but a little bit better than nothing. Okay, let's see what will we get. Okay, we have some plan, initial setup and pre-processing, parse image, initialize empty arrays, green channel interpolation. Okay, refine the green channel using edge detection to better handle edges and reduce artifacts. Okay, nice idea. Red and blue channel interpolation. Use the interpolated green channel to guide. Okay, apply feature where interpolation to preserve edges and gradients. Okay, nice idea. Implement distance-based weighting to prioritize closer pixels. Okay, makes sense. Edge detection and preservation, false color suppression. So plan looks okay, but again, it looks like just rephrasing what I already provide, my requirements, basically rephrasing all my requirements. Nothing new. Let's take a look on the implementation. So constructor, get pixel, it's not interesting. Okay, initial green interpolation. So what's happening here? Bilinear. If is green. Okay, so it's does absolutely the same. It uses like top, left, right, and bottom pixels. The only problem, improvement, it's actually check if it's green. If this pixel is actually green, that it includes only this pixel in this case, only for green pixels. Okay, improvement from previous idea, for previous like code, which we saw previously. But why it's called bilinear interpolation is just like averaging. Okay, red and blue channel interpolation. For this, it does what? If it's red, is this red? Interpolate blue at red. Interpolate red at blue. Otherwise, okay, so it calls some interpolate blue, interpolate red. We have some two functions. I hope we will see them later. Let's just assume that it does something. Okay, edge detection. Okay, Sobol operator for edge detection. Okay, so it will apply matrices to detect edges. Okay, basically we are looking for vertical and horizontal edges here. Yeah, multiply, sum up, and edges. Okay, so we detect just edge detector have. Okay, false color suppression. I will iterate over all image. Okay, so somehow it detects colors which are significantly different, and if so, it just replaces them, then it averages. Okay, I never implemented this algorithm before. Maybe it will work, I don't know, I need to test it. Adaptive interpolation based on local content. Okay, this is interesting. Okay, and we iterate over image, calculate gradient. Okay, it's horizontal and vertical gradients. Basically, we are checking differences on vertical dimensions. Okay, and and we apply horizontal or vertical interpolation. Just to explain what's happening here. So basically it will like check difference between vertical pixels and horizontal pixels. And if delta, for example, between 2 and 8 is bigger than between 4 and 6, this means that we have horizontal line. And in this case, it makes sense to interpolate. So if line is horizontal, we won't interpolate in horizontal direction. Otherwise, we want to interpolate in vertical direction. And if and usually actually let's return to the code. And usually there should be third option. If delta is less some threshold, we just use like averaging, because there is no edge, actual edge detected. Okay, reduce noise. Let's see how it will reduce noise real quick. Filtered green. Okay, it's simple median filter. Basically, it's applying only for green color for some reason. I don't know. It goes again Windows 3x3. It's put all values into array, then it's sorted and uses so it's not like averaging, it's actually like using finding pixel which was the average value with median value. Okay, like I don't understand this algorithm when we have like only a few pixels available. Like for green, what can we interpolate? Let's see on green channel. And for example, if we interpolate, I don't know, this pixel, right? We have 3x3, like 1, 2, 3, 4, 5 pixels only. I don't know. I feel it will be just random. It can create more noise than reduce noise. But I will try to test this algorithm. It's quite interesting. Okay, Demosaic. So initial green interpolation, interpolate red, blue. Is green, is red, is blue, interpolate. It's actually never implemented. Blue at red at blue interpolation, interpolate red at green. So all these functions somehow left out of the scope, unfortunately. So this algorithm is not functional, unfortunately, because like pieces of code is they're missing. Let's try. Hey, let's ask to implement them, please. Let's see if it will be able to implement this code. Okay, initial green channel interpolation be linear. So it's provides the same code from what I see. Yeah, I hope. Why it's providing full code? Okay, let's wait. Oh my gosh. So this is basically how current, let's say, AI actually works. So it won't like replace engineers, software engineers currently at this level of functionality, because to make something, to actually create something working using these tools, let's say LLMs as tools, it's still quite complex and challenging task. You need to overcome all these limitations, all these problems, and it's not a picture which we see in media, because like, hey, AI will steal engineers' jobs. So far, we need so many engineers to make this work at all. So eventually, maybe it will be better. But currently, all the current versions of AIs, it's not yet there. Okay. Okay, so we have interpolate blue at red. Let's take a look. It's interesting. Check surrounding blue pixels for their corresponding green values. It got checks -2, -1. Okay, so it goes with window 5x5. Let me show you how it works. So this is like window 5x5. And if we interpolate blue at red position, blue at red, this means that we are interpolating like here. We are trying to interpolate blue pixel for pixel number 13 here. And what it will do, it will get pixels from null. Why null? Okay, probably if just edged it. So it will get maybe just to handle edge of image probably this function will return null if we're trying to reach pixels outside of image boundaries. Okay, for blue, we will add color from these pixels. I don't understand. Basically, it compares for 2, but it gets only -2. And at -2, we don't have blue information. We have green. And so we get actually green color. Then we calculate green at red. Okay, so it applies this guiding. It's not working algorithm. I can't understand it, sorry. Basically, green at red, it's current pixel from what I see. Currently, so if, let's imagine that we interpolated green already, so we have green in any pixel. So we get green from pixel number 13. Then we subtract green from pixel 11. Okay, so we find difference between green pixels here and there. But for some reason we get information from pixel number 11. It's like it's blue, it's not red. Why we compare? Why are we guiding blue interpolation with red interpolation? It's incorrect. And by the way, we don't have blue pixel at all in this area, so we have only green information. So it's I don't know. From my point of view, it's bullshit. The same story happens for +2. For +2 we have actually red color, okay. But again, we will get for blue color, for blue pixel, we'll get value from red pixel. It makes no sense. And -2 and +2, the same story for vertical. For like from pixel 3 and pixel 23, these are green pixels. We don't have blue color there while we try to do something. So this algorithm is not working, at least for this position. Okay, so let's make some conclusions. So after a few attempts, I'm not able to get any algorithm which even close to something reasonable out of ChatGPT 4.0 currently. So this means that like ChatGPT is way off from like production use for writing code, at least out of the box. So maybe you can construct some additional tools on top of ChatGPT, like this Devin, like Monte Carlo tree search. So basically you can try to brute force. You can generate thousands versions of this code and then pick something usable out of this. But it's not right solution, at least for me, from my point of view. So currently I just can't write code using ChatGPT, unfortunately. At least I can't write something novel. Maybe I can write some Snake game or Tetris game, something which is already was done by like million times by many people, and for which code is available on GitHub, whereas ChatGPT can learn from. But it cannot create new code for me, especially when I don't provide exact, very precise instructions. So here we are like, I provide very general instructions and I expect that it will be smart enough to understand what I want to do. Unfortunately, with this level of details, it just doesn't work. It just don't generate any meaningful code. So that's it. Thank you for watching and see you next time. Bye bye.